giant problem with lots of words, it's nice to see you. It really is nice to see it because giant problems with lots of words usually have simpler math to compensate. So let's see if we can figure out what it's asking. A scientist mixed 3 chemicals, R, S, and T, in a glass container. I'm just going to draw a little glass container. I'm just going to draw it. R and S and T are hanging out in here. Woo. The amount of R is 3 times the amount of S. And I'm going to write that down as I go. R equals 3S. I hate it when they use S as a variable because it looks like 5. If you're doing this on your own, you could use whatever you want as long as you keep it consistent. You could even cross it out and write something else there. The amount of T is 1/6 the amount of S. T equals 1/6 S. Okay, what is the ratio of the amount of R to the amount of T? Well, the first thing I'm going to do is set up a ratio of what we know. R to T is the same as 3S to 1/6 S. So far, so good, yeah? Now we're going to pick numbers. This isn't necessarily one where you have to pick numbers, but I think it's a good candidate for it because I could just try out things here, right? Pick out numbers that I could plug in for S and see what happens. So I'm going to be smart about it and pick a number that is a multiple of 6 so that I don't have to worry about fractions anymore. So the number I'm going to pick is 12. Let's do 12. Okay, which means let's do our ratio here. 3S is 3 times 12, which is 36. Ratio 1/6 times 12 is 2. Now, we're not done because that's not an answer choice, but we can reduce this just like a fraction. So, and if it helps you to look at it like it's a fraction, I'll write it that way. So 36 to 2 is the same as 36 over 2, which is the same as 18 over 1. Let's convert it back to ratio form, colon form, so that we can get back to the answer. It's this one. Don't let E trap you. Make sure that you're doing R to T, where R is on the left and T is on the right. R is the bigger one, so R is 18.